He discovered that the solar system is heliocentric and not geocentric, which means the sun is the center of the solar system.
We put a plastic cup without water on top of the paper, and it stood up. And the second try was that we put water in the plastic cup, and it still stood up because we folded it.
Alright, so our project is called the kaleidoscope, and we hypothesized that if we change the shape of the kaleidoscope, that it will affect the lighting and reflection of the whole kaleidoscope. So we made a triangular one and then a rectangular one, and we asked 10 people if they will evaluate or judge our kaleidoscope, and 8 people liked the triangular one, and they thought that they liked this one more because of the surface area and volume. They thought that because of the surface area and volume was smaller, more reflections would be able to bounce off, giving more lighting to see through the kaleidoscope.
My variable is the paper, because the paper is being changed by being folded into smaller creases to be able to hold up the cup of water. And my experiment is on Copernicus, and he was born in northern Poland, and he was mostly known for his exploration of space and our solar system. So, our data, the first 3 times I tried with regular sheets of paper, it failed. When I tried it with 2 older sheets of paper, it passed. And in conclusion, my hypothesis was correct, but it was also incorrect because our hypothesis stated that it would use 2 to 3 sheets of paper, but it actually only needed 1 to 2.
My experiment is the pendulum experiment, which I conducted with my group. Based on the question, does the weight, the height of release, or the length of the pendulum affect how fast it makes one complete oscillation or swing? It was originally conducted by Galileo Galilei. He was a famous Italian astronomer during the Renaissance.
That one didn't work as much. So you could do a compare and contrast.
The big one didn't work because it needs more force, and the gallon was not enough force for the rocket to fly. Also because Stephanie didn't tighten it so much.
And the smaller one had less weight, and it was easier to fly. And it was easier to launch it because it didn't need as much force, and it would easily just fly.
Like imagine a fat man.
Yeah,
on a
and the
swing.
skinny man would go like
Higher, fat man.
And since this one got lower, it flew lower, and this one flew higher. You could do a compare contrast. Yeah. You could see that we proved our hypothesis right, that this one flew higher, that one didn't, because this one had less weight. This one it was more loose and contained too much weight.
Lo calculamos todo, utilizamos el triángulo, el volumen era 40 centímetros, la área del triángulo era 32.8 y del cuadro era...
And we hypothesized that the tennis ball would bounce higher because it weighs less due to its hollowness. And the variable we changed were the balls, of course the tennis ball and the golf ball, and the results averaged out that the tennis ball bounced on average 1 foot higher than the golf ball. So we can conclude our hypothesis was correct and the tennis ball bounced higher.